Hello everyone, welcome to Homework Help. If you find the video useful, please subscribe to the channel. In this video, we'll solve rational inequalities algebraically. As per the problem, solve each inequality and we'll solve these two inequalities. Let's start with the inequality on the left side, 4 over x minus 3 less than 1. In order to solve an inequality, we should move all non-zero terms to one side of the inequality and the other side should have just a 0. In this inequality, we should move the 1 to the left side by subtracting 1 from both sides. Next, we can combine the terms on the left side. The denominator of 1 is 1. We can combine these fractions by finding a common denominator. The common denominator is x minus 3. We should multiply 1 over 1 by x minus 3 in the numerator and denominator. Now we can combine these fractions. Next, we can get rid of the parentheses in the numerator. We can distribute the negative sign in the parentheses. That changes the sign of the terms in the parentheses. Next, we can combine like terms in the numerator. 4 plus 3 is equal to 7. Next, we should find the x-intercept and vertical asymptote for this rational function. For x-intercept, we should set the numerator equal to 0 and solve for x. I get x equals 7. Next, we can find the vertical asymptote. We set the denominator expression equal to 0 and solve for x. I get x equals 3. We can use the number line method to solve the inequality. We should draw a number line. And show the x-intercept and the vertical asymptote values. These 2 points divide the number line into 3 parts. We'll have to test the inequality in the 3 parts of this number line. We'll use a test value from each part. On the left side of 3, we can use the test value 0. Between 3 and 7, we can use the test value 4. To the right side of 7, we can use the test value 8. We should input x as 0, 3, 4, 7 and 8 in this expression and see which of these values satisfy this inequality. 7 minus x over x minus 3 less than 0. Let's start with x equals 0. This fraction has a negative value, so it's less than 0. That means the interval on the left side of 3 satisfies the given inequality. Next, we can sub in x as 3. At x equals 3, the expression becomes undefined, so x equals 3 does not work. Next, we can sub in x as 4. I get 3, which is greater than 0. Therefore, the interval between 3 and 7 does not satisfy the inequality. Next, we can sub in x as 7. Since we are looking for x values that will make the inequality less than 0, x equals 7 does not work. Next, we can use the test value 8. I get negative 1 over 5, which is less than 0. That means the interval to the right side of 7 works. So the solution for this inequality can be written in inequality notation as x less than 3 or x greater than 7. In interval notation, the solution can be written as this should be the final answer for the first inequality. Now we can solve the second inequality, 7 over x plus 1 greater than 7. The first step is to move all non-zero terms to the left side of the inequality. Next, we should combine the terms on the left side. The denominator of 7 is 1. The common denominator is x plus 1. So we should multiply 7 over 1 by x plus 1 in the numerator and denominator. Next, we can combine the fractions. Next, we can get rid of the parentheses in the numerator. We can distribute negative 7 into the parentheses. Next, we can combine like terms in the numerator. Next, we should find the x-intercept and vertical asymptote for this rational function. Let's start with x-intercept. For x-intercept, we should set the numerator expression equal to 0 and solve for x. I get x equals 0. Next, we can find the vertical asymptote. We should set the denominator expression equal to 0 and solve for x. I get x equals negative 1. Now we can use the number line method. We can plot these values for x-intercept and vertical asymptote. These two values break up the number line into three parts. We have to use a test value from each part. On the left side of negative 1, we can use the test value negative 2. Between negative 1 and 0, we can use the test value negative 0.5. to the right side of 0, we can use the test value 1. Next, we can sub in x as -2, -1, -0.5, 0 and 1 by 1. In this inequality, -7x over x plus 1 greater than 0. We have to find which of these x values will satisfy this inequality. Let's start with the test value -2. I get -14, which is less than 0, not greater than 0. So the interval on the left side of -1 does not work. Next, we can sub in x as -1. Seven over 0 is undefined. Therefore, x equals -1 does not work for us. Next, we can use the test value -0.5. I get 7, which is greater than 0. That means the interval between -1 and 0 satisfies the inequality. Next, we can use the x value 0. I get 0, but we are looking for x values for which -7x over x plus 1 is greater than 0. So x equals 0 does not work. Next, we can use the test value x equals 1. I get -7 over 2, which is less than 0. That means the interval on the right side of 0 does not satisfy the inequality. Therefore, there is only one interval that is the solution for the given inequality. We can write this interval in inequality notation as we can write the solution in interval notation as this should be the final answer for the second inequality. So these are the steps you have to keep in mind to solve a problem like this one. I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.